Hi everyone, this is a quick review of rationalizing denominators. So our purpose here is that rationalizing denominators is proper notation, and this really just is a notation thing. It doesn't change the value, it's just the way people want things to look. But the good news is we only have a few common cases that occur, so we're not having to go through different kinds of roots. I'm only going to have to deal with square roots right now. So our goal is, given a over the square root of b, where b is a number greater than 0, we're going to multiply by the square root of b over the square root of b. We know square root of b over square root of b, that's just equal to 1, right? Anything divided by itself is 1. So when we multiply by this, we're not changing the value of our fraction, we're just changing the way the answer looks. So we'll start with this example. I have 5 over the square root of 2, and I told you we are going to multiply by the square root of 2 over the square root of 2. In the numerator, I have 5 times the square root of 2. The square root of 2 times the square root of 2 is 2. So now we have rationalized the denominator. The denominator is now an integer, it doesn't have a radical, and it just looks a little different. Let's try again. I have 1 over the square root of 7. I'm going to multiply by the square root of 7 over the square root of 7. 1 times the square root of 7 is just the square root of 7. And then in the denominator, we see when we multiply the two square roots, we just get the 7 that pops out. This time I have 6 over the square root of 2. I'm going to multiply the square root of 2 over the square root of 2. So I have 6 square root of 2 in the numerator. In the denominator, square root of 2 times square root of 2 is 2. I did this one on purpose to show you that if you can simplify after you've rationalized, then you should do that. So 6 over 2 we know is 3, so I get 3 square root of 2. Right? This one says 8 over the square root of 8. Same thing. I do the square root of 8 over the square root of 8. In the numerator, 8 times the square root of 8. In the denominator, I get 8. Now look, this 8 and 8, that can cancel, and our final answer is the square root of 8. This one particularly is important. I think you're going to see it quite a bit, so I have a little shortcut. If I have b over the square root of b, it's just the square root of b. Kind of what I see here is b could be factored into the square root of b times the square root of b. So if I have square root of b times square root of b over the square root of b, you can see 1 cancels. Right? If that's helpful, I want you to use it. If it's not, just continue to rationalize. So I have 3 quick problems for you to try. My idea of you try is stop the video, do these 3 problems, then come back and listen to the answers and make sure that you're getting it right. So the first one, 11 over the square root of 11. If you took the shortcut I just had, you would know it's the square root of 11. If you need to see it written out, then I can do that. Square root of 11 top and bottom. I get 11 square root of 11 over 11. I cancel. There's my square root of 11. So same thing either way. 1 over the square root of 3. I have square root of 3, square root of 3 that I multiply by. In the numerator, square root of 3. In the denominator, just the number 3. The last one says 4 over the square root of 6. So multiply the square root of 6 over the square root of 6. I have 4 square root of 6 in the numerator. I have 6 in the denominator. 4 and 6 are both even, so I can reduce them both by 2. So 4 divided by 2 gives me 2. Still have the square root of 6. 6 divided by 2 is 3. This is my final answer. This will be coming up in lots of things that have to do with trig and trig ratios, so it is something that you need to become comfortable with. If this was not enough of a review, I think it's important to Google some practice or something so you can do more of these problems, because you need to be able to just fly through this rationalizing this semester.